Let's talk about velocity time graphs a little bit more than we already have. This velocity time graph looks a lot like the one that we saw before in that it has nice, crisp, straight lines, no curvy stuff going on. What can you tell about the motion of the object looking at this graph? Well, let's look at it in this time interval right here. The velocity is, here's 0, this is negative velocity, and this is positive velocity. So the object is, the velocity is getting farther from 0, so it's going faster and faster and faster. And what happens right here? Now, don't say it doesn't move, because look, it has a velocity of 60 meters per minute. So it is moving, it's just not speeding up or slowing down. So now let's look at what happens in this time interval. Well, the velocity gets less and less and less, so it is slowing down. This would be, the slope is negative. You know, if it moves up and to the right, that's a positive slope. And if it moves, I'm sorry, that should be an acceleration. Positive slope, positive acceleration. If it moves down to the right, then that's a negative slope. So you have a negative acceleration going on here. Let's talk about what happens right here. Our line crosses the 0 velocity line. So this object sped up. It went with a constant speed for a little bit, for 5 seconds. And then it slowed down, and then it came to a stop. It didn't stay there because it crosses the x-axis, and so its velocity is 0, but not for very long. Now it's turning around and going the other direction for this little bit. It went from having a positive velocity here to having a negative velocity here. Now remember, positive and negative indicate direction. So speed up, constant speed, slow down, come to a stop, speed up, going in the other direction. Now, this is still a negative acceleration. Notice the slope doesn't change. So the acceleration is the same from here all the way to here. But we said it was slowing down and then speeding up. But it's a negative acceleration. Positive velocity, negative acceleration, slow down. Negative velocity, negative acceleration, speed up. So speeding up but going in the other direction. And then here it reaches a maximum speed of 40, velocity of negative 40, and then it starts slowing down again, still moving in the same direction. This is speeding up, this is slowing down, and then coming to rest, a velocity at 0 at 55 seconds. The significance of slope, remember, the slope is equal to the average acceleration. Positive slope, positive acceleration, negative slope, negative acceleration. Remember that physics lab site we went to last time? Let's go there again. We'll look very quickly at these lines representing the velocity versus time for 4 different objects. Let's answer these questions about this graph. Which of these objects is moving in a negative direction and losing speed? Well, none of these objects is moving in a negative direction. If this is the origin, and there's no other axis, so this has to be the origin, all of these are positive velocities. So they're all moving in a positive direction. So A is bothering you because it's got a negative slope. That just means it's slowing down, moving in a positive direction, negative acceleration, slowing down, going from a high velocity to close to a 0 velocity. So there's no match. There's nothing that's moving in a negative direction and losing speed. There's nothing moving in a negative direction on the graph. Moving in a positive direction and gaining speed at a slow rate. All of them are moving at a positive velocity, but there are 2 of them that are gaining speed, where the velocity is getting higher on this axis, and that would be D and B. So which of those would be gaining speed at the slow rate? That would be D. Traveling at a steady rate in a positive direction. Well, the steady speed would be C. A flat line on a velocity time graph doesn't mean it's not moving, it means it's not speeding up or slowing down. At rest for an extended time. None of these cross the x-axis, which would correspond to a 0 velocity, at all. So none of these is at rest other than these 2 right at the very beginning. But none of these hang out with a 0 velocity. They're trying to trick you and make you go, ooh, see, it's flat. That was on a position time graph. On a velocity time graph, if the value is not 0, then it's moving. The speed's just not changing. Moving in a positive direction but losing speed. That's A. It's moving in a positive direction. All of these velocities are positive, and the velocity is getting smaller. Moving in a positive direction, gaining speed at a rapid rate. Well, B has a steeper slope than D, and so the rate at which the velocity is changing here is faster than this one. During which time interval did this object travel in a positive direction? Positive velocities, 0, negative velocities. So from 20 all the way to 30, the object's traveling in a positive direction. During which time interval did it travel in a negative direction? Anytime it's below the x-axis where the y values are negative, it's traveling in a negative direction. Now I would like to look at this little box. It's got some information that we need. Velocity is determined by the height of the graph, the y component. Acceleration is determined by the slope. Displacement, we haven't talked about this before. Displacement is found by calculating the area bounded by or under the velocity time graph and the x-axis, excuse me. I forgot how to talk there for a second. Displacement is found by calculating the area bounded by the velocity graph and the x-axis. I'm going to go back here for just a second because I have a picture of that same graph. So, area under the curve. That would be finding the area all under here or here. The area between the line we've drawn, the plot, and the axis. Now this would represent a positive displacement because it's above the x-axis, and this would correspond to a negative displacement because it's below. So in that time when it's traveling positively, if we find the area under that curve, we'll find out how far it went. We can find out how far it went negatively during this time interval, again, by finding the area under the curve. And if we add the two together, this positive value and this negative value, then we'll get the displacement for the entire time interval. Now we're going to have to be able to, bring my browser back up, calculate areas. Well, we can split this into some triangles and a rectangle. See, triangle right here, and a rectangle to find the area. Well, it says first 10 minutes, so this is the first triangle. So it's, look at exactly what we're trying to find the area of. The first 10 minutes would be the area right there. Well, how do you find the area of a triangle? The area of a triangle is 1/2 base times height, right? Sorry. So 1/2, and the base of this triangle is 10 minutes. And the height of this triangle is 20, 40, 60 meters per minute. Minutes cancel. 10 times 60 is 600, and half of that would be 300 meters. Look at the units and see how they work out. This is minutes, that's minutes, and they cancel, and you're left with meters. Pull the browser back up. Okay, so how far did it travel in the first 10 minutes? 300 meters. Briefly describe the behavior between 10 and 15 minutes. That would be right in here. The velocity is constant. If we wanted to know how far it traveled, we would find the area of that rectangle. That's 5 minutes on a base and 60 meters per minute on the height. What is the average acceleration between 10 and 15 minutes? Well, it's 0. It's flat. If you did y2 minus y1, well, the y's aren't changing, so there'd be a 0 in the numerator, and so it gives you a 0 slope, no acceleration. How far did it travel between 15 and 30 minutes? Well, here's another triangle. The base is 15 minutes, and the height is 60 meters. Go back where I can do that math. 15 minutes, and that was 60 meters per minute. And 15 times 60, well, let's see, 15 times 6 is 90, so 15 times 60 would be 900 meters for the displacement during that time. Trying to pull my browser up again. Oops, there we go. All right. Well, I thought I did. Okay. How far did it travel between 30 and 40 minutes? It traveled in a negative direction. So we have to find the area of this triangle, and it's a negative displacement. We have a height of 40 and a base of 10. 40 times 10 is 400, and half of that would be 200, so 200 meters for this interval right here. And how far did it travel between 40 and 55 minutes? The height is 40, and the base is 15. And hold on a second. 40, 1/2, 40 times 15. I'm going to have to check, and we'll do this math, and then I'll go back and make sure that I multiplied the right stuff. Half of 40 is 20, and 20 times 15 is 300 meters. And it'll be negative because it's moving in a negative direction. This area right here and this area right here are both negative. And it's, yes, 40 was this, and that value is 15, so the math was right. Okay, well, that is the end of our velocity time graph session. Thanks for your time.